Today, on how it's made. Chemical tank pressure vents. Candy wafers. Food trucks. And traditional ropes. When vapors build inside chemical tanker trucks, special pressure vents prevent the buildup of pressure or vacuum due to temperature changes or shifting during loading and unloading or during transport. They maintain the balance between the forces that want to implode or explode the chemical payload. Pressure relief vents are standard equipment in the chemical transport business. They ensure that the tanks can hold up to the pressures inherent to the industry. Production starts with a bin of casting-grade wax pellets. They'll use these pellets to mold wax models of some of the parts in a process known as lost wax casting. They feed the pellets to an injection machine. This machine melts the wax as it forces it into a mold of the vent's lower housing. The wax cools and solidifies. They fuse 4 of the models to one wax tree stand and leave them to cure for a couple of hours. Then, gripping a metal rod that's been molded into the center of the wax tree, a worker dips the models into a spinning slurry of ceramic. He removes the stand of wax models and twirls it a bit in order to fully drain off the excess ceramic. This is the first of several ceramic coatings. Between coatings, he applies silica sand to the wet ceramic. In this chamber, the sand rains down onto the ceramic, creating a stucco effect on the surface. This first stucco is finely granulated, but the next ones are coarser. By building up layers that are progressively more coarse, he creates a ceramic shell with the desired thickness and strength. To apply the final coarsest layer of sand, they pump air through the sand as the worker dunks the models into it. It's the best way to ensure uniform coverage of the coarser, heavier sand. They bake the forms, and this melts out the wax, while hardening the ceramic into shells. Next, a team pours blazing liquid steel into a ladle. Another worker then removes the ceramic shells from the oven. The temperature of the shells is around 1650 degrees Celsius. The workers transfer the ladle full of hot liquid steel over to the shells and carefully pour it into them through the hollow tree. They add a chemical sealer and top the molten metal with a piece of ceramic fiber insulation. They leave the castings to cure. It takes about 3 hours for the steel to solidify, and then a worker shatters the ceramic to reveal the steel vent housing parts. They slice the parts off the tree using a powerful circular saw, and they clean off the ceramic residue. At least 15 computer-driven tools machine the pressure vent housing part to precise tolerances. After cleaning and polishing, the part is complete. It's time for assembly. The worker starts with the top of the pressure vent. He inserts a large spring to aid in the pressure relief action. He adds a metal plate that seals the top part of the vent to the lower one, and then seats the lower vent housing on that metal plate. He moves the assembly under a hydraulic ram. The ram presses the lower housing, the sealer plate, and the spring to a specific tension. He then screws the lower housing to the top of the vent. He attaches a metal ring that's inscribed with the vent's model and flow rate. He rivets it in place at the top. The chemical tank pressure vent is now complete and ready to be put to the test. The technician screws it to the test stand. He activates a system that forces compressed air into the vent. He confirms that the vent works at the desired setting. Once approved, he attaches a cover to shield the vent from rain and snow. Using a laser, they etch the serial number into the top to allow the pressure relief vent to be tracked if needed. Now complete, this vent should prevent hazardous situations.